Hi Sam, how are you?
Hi sir, doing good. How about you?
So our today's Sam discussion is very relevant discussion, and that is related to the hot research areas in
Yes, sir.
your field, that is AI field.
Yes,
And
sir.
before we go forward, Sam, I would like to highlight one of the misconception among the student community here. Many students believe that AI, ML, data science is domain of computer science.
Oh
So
no. Yes.
they do not, they don't understand that it is the application domains, or they are the application tools.
Exactly.
Whether you are mechanical engineer or you are agriculture scientist or you are from any humanities background, AI, ML are tools. These can be used anywhere.
Yes, sir.
So
Yes, sir.
that thing in my mind, first I would like you to comment on that also.
Yes,
Who
sir.
can make career in AI, ML, and
Yes, sir.
then hot research areas in these fields.
Sure, sir. Sure, sir. Thank you. So, as you said, AI is exactly now an interdisciplinary subject. Now, it's not only computer science subject basically. So, if you are coming from medical domain, biology domain, or let's say physics domain, you are as much as suitable than as a computer science student. So, even AI is spanning its wings in different sectors like physics informed neural networks, for example, bioinformatics or bio inspired artificial intelligence. So there are multiple different domains that are opening in within AI itself to make AI robust. Because what exactly we are seeking in AI is a true artificial general intelligence which can replicate humans, or basically replicate human behavior, right? That's what we are expecting with minimal supervision. As a 2 year child knows how to deal with or they know basically if they jump they would fall, right? But today's AI is not that robust. So to make robust, or to make AI robust, we want to implement physical laws and everything. So that's why every domain is or every student coming from different domain is required to make AI robust. And that's why even like renowned scientists or renowned AI practitioners are coming from physics, mathematics, and all those background, not computer
Mhm.
science. Because 20 years ago, 30 years ago, it was physics, it was
Mhm.
mathematics that
Mhm.
was prominent in research, right? So
Mhm.
those renowned scientists are coming from different background, and that's why it's important, in fact, to coming from interdisciplinary background and having some skills in machine learning or Python, and then you can become adjustable or become adaptable to study AI, and then you are basically easily selected. So,
Okay.
uh, yes, sir. So, if you allow me, I can quickly
Yeah.
describe five
Yeah, yeah,
topics.
please go ahead.
Yeah. So first research area that's very hot right now is generative AI. I'm also
Mm.
doing PhD in generative AI, and
Okay.
generative AI is nothing but what we are expecting is whatever data you provide, be it audio, be it
Mm.
video, be it image, any signal that you provide, you are trying to replicate it or reproduce it, but not exactly same. You are trying to interpolate it, and once you are interpolating, it's no longer the original data, it's the hallucinated data. And
Mm.
what we are trying in generative AI is basically trying to generate the hallucinated data as real as possible to the original data. So you can think of it as, let's say I give you 1,000 or 1 million images of faces, different faces,
Mm.
and I ask the AI model to generate a new face, and that will
Mm.
be interpolated between all those 1 million faces. Same way
Mm.
we can generate voices. For example, we can train a model to basically learn Barack Obama's voice, and it can
Mm.
actually generate it. You
Mm.
can just ask, and you can just type, and it will basically reproduce the audio of Barack Obama. So this is how it works. So
Mm.
generative AI is one thing. Then there's another thing called as explainable AI. Explainable AI, I remember I was studying even in IIT Jodhpur previously, and it's very nice subject to study. If you are a researcher, then you would know about explainable AI. What we are
Mm.
doing in explainable AI is basically auditing AI. So if AI or machine learning model or deep learning model is actually saying that okay, by this much of probability this is going to happen, then we want to ask why exactly you chose this particular prediction label or prediction probability, and what was the reason that you predicted something like that, right? So we want to dissect, or we want to see what exactly happening inside the AI model, and this is what explainable AI is. And people are using it's actually important nowadays, because if you want to make money in AI, then this is the very right subject, because right now companies want to hire AI auditors, AI inspectors, right? Because this is like a hot research field, and PhD is very much required to become an AI auditor nowadays. So this is like very hot topic. It's not that people in India are aware about this a lot, because it requires a lot of funding to study AI auditing. You need to study, you need to spend a lot of time. So funding is somewhat required to study AI auditing, and this is where US countries like US, Europe, continent like Europe leads, right? Because they have resources, they have funding, and they can train you to perform AI auditing, right? So that's why it's important to study this as well, or at least you should know about it. Third research area, sir, I would place it as quantum AI, because right now quantum computation is being studied everywhere in the world. People have not seen very much prominent results right now, but they are expecting that it could be promising after 20-30 years. The core idea here is to leverage quantum or physical laws of quantum superposition in machine learning, and that is where you can learn multiple optimization or multiple techniques to optimize something. So assume it as a problem that is being solved in millions of years can be solved in just 10 minutes using quantum AI. So this is what quantum thing is utilized as. Then, as I was mentioning, there's one research, very hot topic that is being pursued by mechanical engineer guys, if they want to become, if they want to come in AI, is is called as physics informed neural network.
Okay.
So when they are basically building a neural network or a machine learning model, then they also want to infuse physical laws. So, for example, let's say a person is doing fluid dynamics. I'm not a mechanical guy, but I'm just quoting. Let's say you are doing a fluid dynamics, and you want to infuse those fluid dynamic laws in your training algorithm. Then you need mechanical background, right? You need physics background. A computer science guy cannot do this. So because I don't know all these laws and everything. If you know, if you are a mechanical guy knowing deep learning or how to train a deep learning model, then you are like completely done. You are good as competitive as a computer science guy, or I would say you are more eligible for that position, because mechanical engineering domains are or departments are also releasing so many PhD positions in AI, right? So if you are aware about at least a bit about how to program Python or like that, you are welcome, more than welcome there. And last topic, I would place artificial general intelligence, which is closely related to biology. So what we are studying in artificial general intelligence is about how biological systems work, or they call it as agents. So they want to study how agents naturally adapt the environment, how they evolve in an environment, how they capture energy from the environment, etc., etc. So we try to infuse a synthetic genome, or a synthetic, I would say, cell, and we study the dynamics of that cell, how it performs with the abundant energy, how it performs with other cells, how it interacts with other cells. Because if you remember, if you know, then probably you would try to relate it as real cell biology, because in real cell biology, what we are doing, we are trying to study the cell interactions. We are trying to study the genealogies. We are trying to capture how randomness, or how random interactions of cells become tissues or organs like that, right? So all these things are very much prominent in AGI. So if you can summarize all these five topics,
Five.
I told you all five topics that are hot from different domains. These are not pure
Yes.
computer science, but
Mm,
they all are
mm,
different domains, right? So
So
that,
now same. I'll request you to again summarize all the five. Number one, number two, number three, number four. Starting from AI, generative AI to general AI. All the five.
yes, yes, sir. You captured it very nicely from generative AI to general AI. This is what
Yeah.
actually it is. So
Mm,
generative AI, yes, you
number
come
one.
up with any signal. Number one
Mm,
is generative AI. You come up with
mm,
any kind of signal. You want to
mm,
generate it
mm,
synthetically,
mm,
and that is as close as the real data. And
mm,
this is where you can use that synthetic data for other
mm,
purposes.
mm,
Second is explainable AI, which is AI auditing.
mm,
The major use of explainable AI or AI auditing is in finance, legal,
mm,
and
mm,
law and regulations section. So
mm,
if you
mm,
are coming from that background, you can utilize it.
mm,
Then third is quantum AI. So people
mm,
coming from physics background or let's say chemistry background can very much leverage this domain.
mm,
Then fourth topic is physics informed neural networks. This is specifically when mechanical background student or physics background student can leverage it. Even civil engineering guys can also use it because they also study some physical laws in their engineering, right?
mm,
And the fifth one is artificial general intelligence, which is very prominent by, or the whole domain is very much captured by biologists because
mm,
they are required in need to study AGI because they try to correlate real world cellular
mm,
interactions
mm,
in
mm.
artificial world.
Okay, wonderful. So these are the five hot research topics, same, and I'm very sure the students who are listening to our conversation, they will
Yes, sir.
surely, try to pursue the domains in these particular areas. Maybe if they are in that process where they can choose a
Definitely.
path for them, research path for them, maybe they will consider it. And AI
Definitely.
is every field of knowledge, and I'm very sure, as you give the example from different domains of learning, like mechanical engineering, biology, so I'm very
Yes,
sure the students from different domains they will try to use these tools for better
exactly.
career. So that
Exactly.
brings us to an end of this wonderful session. Sam with you. So look
Thank
forward
you.
to have more such information from you in future. Thank you.